Good day everyone, this is Cheezel and welcome back to my channel. In this video, we will be discussing the trigonometric function. Have you ever heard of the expression soka toa? What do you think this expression means? In this lesson, we're going to focus on right triangle trigonometry. Let's say if this is a triangle theta. Now, there's three sides of this triangle that you need to be familiar with. Opposite to theta, this is the opposite side. And next, the angle of theta is the adjacent side. And across the box or the right angle of the triangle, which is the hypotenuse. That's the longest sides of the triangle. Now, if you recall, this is A, B, and C. The Pythagorean theorem applies to right triangle a squared plus b squared is equal to c squared. But we're not going to focus on that too much. But just be familiar with that equation. Now, let's talk about the 6 trigonometric function in terms of sine, cosine, tangent, opposite, adjacent, hypotenuse. Sine theta, according to the SOHCAHTOA, so S is for sine, O is for opposite at A, and H is for hypotenuse. Sine theta is equals to the opposite side divided by the hypotenuse. Cosine theta is equals to the adjacent side divided by the hypotenuse, and tangent theta or TOA is equals to the opposite side divided by adjacent. So that's the tangent ratio. It's opposite side over adjacent side. Now, we know that cosecant is 1 over sine. So, cosecant basically hypotenuse divided by opposite side. You just need to flip the particular fraction. Secant is the reciprocal of cosine. So, secant is going to be hypotenuse divided by the adjacent side. Cotangent is the reciprocal of tangent. So if the tangent is opposite over adjacent, cotangent is adjacent over opposite. Now, let's say if we're given a right triangles and we have the value of two sides, let's say this is the 3 and this is the 4. And here is the angle theta. Find the missing of this right triangle and then find the values of all 6 trigonometric functions: sine, cosine, tangent, secant, cosecant, cotangent. How to find the missing sides? We need to use the Pythagorean theorem. A squared plus b squared is equals to c squared. So A is 3, B is 4, and we gonna find the missing side C, which is the hypotenuse. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. And if you take the square root of both sides, you can see that the hypotenuse is 5. Now, it's turned out that there are some special numbers. There are 3, 4, 5 right triangles, the 5, 12, 13 right triangles, the 8, 15, 17 right triangle, and the 7, 24, 25 right triangles. And any whole numbers ratio or multiplies of these numbers will also work for examples. If we multiply this by 2, we'll get 6, 8, 10, and can also root or of you multiply by 3, you get the 9, 12, 15 triangle. If you multiply this by 2, you get